Hello everybody, welcome back to Zhan's AI Corner where I use simple plain language to explain AI terminologies. On the screen you see there is a QR code, that's my channel QR code. You can scan that if you want to see more videos. So today I want to talk about is transformers, right? If you probably have you seen that, have you heard about that before? Transformers. Definitely Transformers is not an animation, which is ba 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 ba. That's not that right. So Transformer is one of the architecture which widely be used by the nowadays modern large language modules such as ChatGPT, Gemini, Llama, and Grok. And its architecture which is specialized in processing text. Right. Of course, you can say, oh, why ChatGPT can produce images like a image and also maybe some multimedia media, right? Yes, it is, but originally Transformers is best known for processing text. That's why nowadays most of us we use ChatGPT for chat or produce some text-based content. And the different from Transformers as an architecture, that means there are the other architectures such as diffusion, which is more into images, videos, music. But of course, today we're not going to talk about diffusion. We are talking about transformers. So what I want to talk about today is, so what is transformer, right? What is transformer? Probably I should remove this S, right? Transformer. And how it works, right? In my previous video, which I talk about how the large language module works, I kind of introduced about the transformer over there. But today I want to talk about a bit more about transformer, right? So in transformer is a fundamental architecture for nowadays ChatGPT or Gemini, those AI, which is a algorithm, is an architecture which is process text, right? So it's more about emphasize on attention, right? To make sure like the output and input is based on attention. So in a simple language is, okay, when I enter some text, the large language module based on the transformer is able to understand, right, what's the key meaning of your input. And when I ask the large language module to produce the output, the large language module need to pay attention, which will give the most likely result, right? So that is what about attention is all I need. Attention is all what you need. That's the fundamental principle for transformer, right? So I don't know if you have heard there is two different large language module. One is called encoder, another one is called decoder. If you haven't heard about that, so that's okay. So I give you to tell you, encoder is the embedding large language module, right? In the past, I don't know if I mentioned there is like BERT-based embedding, like a large language module. Or if you are familiar with AWS Bedrock, there is like Titan, right, embedding large language module. And the encoder, which is everybody familiar, ChatGPT, right, Gemini or Claude, right? So they are two different large language module. So in the past, I mean, transformer under this architecture, this two different larger module, they actually work together. But later on, like a lot of companies find decoder this part can work by itself. That's why they take this decoder out from the transformer, still part of transformer architecture, but leverage decoder capability. They invented ChatGPT and Gemini, those decoding large language module, right? And for the encoding part, which is we largely use, like for example, Titan, I mentioned earlier, they're decoding. So what actually are they? So that's what I'm going to tell you now. So for example, when I talk about, for example, my name is Zhan, right? My name is Zhan. This is a message coming. So what happens over there, right? My name is Zhan only have meaning for us, human being, but doesn't mean anything about it for the large language module for computer. So very similar for programming. When you do the program, that program only makes sense to you. But when actually the computer start running the code, it has to translate that into machine language. So what encoder does is translate the text which you understand, my name is Zhan, into a bunch of code which can be understood by the machine. And that bunch of code is called embedding. And in the programming world is vector, right? I think in my I think my second video when I talk about how large language module works, I'm talking about the first step is to tokenize, and then have embedding. The embedding will come up with a bunch of vector, which is a bunch of like a float number, right? Tokenized token is a bunch of the integer. So those embedding is, all right, token 9, which generate tokens. Then come into embedding, which is come up with vectors. Those vectors, we don't know anything about what it means, but it can be understood by the larger module, or actually can be understood by transformer, right? So if you I just want to quickly brief what's the relationship between token and the embeddings. Basically, token is like an ID or is an index, which refers to the meaning, different meaning in large language module knowledge base, right? So the meaning in large language module, they are the vectors, or AKA we should say embeddings. So for example, my name is Zhan possibly be break into multiple tokens like my name is Zhan, right? And each of them will be translated into different token and then will be mapped to different token. And each token is a key, is an index into into a piece of embedding in large language module knowledge base. And that knowledge cannot be understood by you, but it can be understood by transformer, can be understood by AI. So therefore, token is merely just bunch of index, which is mapped to the meaning, right? Which can be which can be understood by the machines, the large language module, and therefore by encoding by this encoder process, the result will come up with a list of vectors. Those vectors representing the meaning of my name is Zhan, but it can be understood by the large language module. So that's their relationship, right? So therefore, so the output for encoder is give a bunch of vector which is embedding. And then normally in the past, when the transformer it works, what happens? It will feed this embedding back to decoder, right? And the decoder will take in two parameters. Parameter one is the embedding, which is here. Another one is what I have output so far. Here, when I say I, is talking about decoder. What does the decoder has outputted? Right. At the beginning, of course, outputted is 0, nothing. In that case, will be something like a start It might not necessarily be start, but there is a signal or symbol which is flag. This is the start of the decoding process. Of course, there is end, right? When they finish. Then you can see there are differences. When we do the decoding process, we enter my name is Zhan as a whole parameter coming to decoder. So therefore, the whole process is much simpler compared with decoder. Why? Because decoder is character by character. First, as I said, embedding, I passing. And then output at the beginning is nothing. Then they start coming to, okay, my name is Zhan. For example, I want to do the translation, right? Please translate my name is Zhan into Chinese or Japanese, right? In Chinese, my name is Zhan is 我, for example. That's Chinese representing mine, right? Probably should I say 我的, which is mine, right? Then taking this word back to the second parameter, which is embedding and the output, then put to the next output, then the next character translation is 我的. For example, like that. Because name, right? Name in Chinese is 名字, right? Then taking that as a parameter, what it means as a input parameter, go back to the same process and keep producing the rest of the words till the whole translation finish. As you see, this is a recurring iteration process. Therefore, when you use tokens, the output token usually is much more expensive compared with input tokens, right? It's because output tokens, it has to be iterated by multiple times before they give you a complete result. And that's exactly why you see like a ChatGPT or many large language module, they output a token one by one. It sounds like, okay, it feels like people are writing text. My name is Zhan, rather than my name is Zhan in one sentence, right? Or like sometimes if you use a localized larger module, you see, oh, why it come up with together? It's simply because the AI lecture module, the cache result, or only when they receive the end signal, then give you the result as a whole. But if you set don't wait for end, just give me when you are streaming, when you have a result, then you will see my name is and same, we will have same behavior like ChatGPT, character by character is come out. So that is transformer, right? And then nowadays, like ChatGPT, Gemini, and Llama, as I mentioned, they use decoder because they don't need people to do translation, like what I said here. So they removed the need for embedding, right? They just based on output and they do the iteration. But if you want to say, okay, in that case, how that decoder knows what the output result is? It's because it has been trained. So yeah, it has been trained already. So it's a pre-trained larger module. In that case, the decoder doesn't need to look at encoding input message. It can just based on the pre-trained knowledge and start producing the output to give you the complete result, right? So that's the basic understanding of how transformer works, right? So in the future, if people ask you, oh, what's a transformer? The simple answer is transformer is one of the architecture which initially introduced by processing text, right? So transformer is architecture widely be used by ChatGPT, Gemini, Llama, Grok. So for those larger modules. And it has encoder and a decoder. Encoder is for AI to translate the input message into something which is vector as a result. This vector into something can be understood by the larger module. And the decoder, which is leveraging the knowledge which AI already know and translate that meaning into the content human can understand. So it's very similar with you hear somebody talk to you, which is like encoder. You receive that message, put it into your brain. That process is encoder. And then when you want to speak, answer the question, and you have some understanding, knowledge in your base, and then translate that thinking process, your neurons process, and produce into a language and communicate, speak it out with that person. So that's the best way to understand what transformer is and what the encoder and decoder is. So hopefully you found this video is informative and helpful. If you like this video, give a like and share with your family, and I'll see you next time. Take care. Good night.